Good morning. Today we'll be moving on to our next lesson, which is still in the exponents and radicals chapter, but we're moving on from exponents onto bigger and better things and moving on to radicals. Just a reminder, please take notes during this video because this will be on a quiz at some point. So what is a radical? A radical is just a symbol that we use in math that means that we're taking a root of a number. So we can either take a square root, a cube root, fourth root, fifth root, so on and so forth. So we have our square root, which looks like this, cube root, our fourth root, and then a seventh root. So notice how each of these has a little number outside of the radical, except for our square root. We don't put a 2 outside of a square root because we use square roots so often that when there's no number there, we just know to assume that it's a square root. So how do we find roots? Well, for a square root, it's any number that's multiplied to itself that equals that number. So for 36, we have 6 times 6, which equals 36. Cube root, we have a number that's multiplied 3 times. Fourth root, that's multiplied 4 times to equal that number. And then a seventh root, it's a number that's multiplied 7 times to equal the number inside the radical. So radicals are the opposite of exponents, and because of this, they cancel each other out. So if we have a square root of, or if we have a root of some number, for example, a cube root, but then we raise that root to the third power, this cube root and the cube, because they're the same number, will cancel each other out. And so what we're left with is just the number inside the radical. So the radical and the exponent go away. So now some rules of radicals. We have 2 different rules. We have a rule for multiplication and then a rule for division. The multiplication rule says that if we have 2 radicals with the same root, so a cube root and a cube root, a fourth root and a fourth root, fifth root and a fifth root, when they're multiplied together, you can combine the numbers inside the radical under one radical and multiply them. So if I have a to the n times b, if I have the nth root of a and the nth root of b, this is equal to the nth root of a times b. So an example, if I have the cube root of 2 times the cube root of 32, this is equal to the cube root of 2 times 32. Then this equals the cube root of 64, because 2 times 32 is 64. And since 64 is a perfect cube, we can take the cube root of it and we get 4, because 4 times 4 times 4 equals 64. Okay, so now I want you to pause this video and try this problem. So moving on to our division rule. So the division rule is similar to the multiplication rule, just now we're using division. So if I have the nth root of a divided by the nth root of b, so again, they have to be the same root. So it has to be an nth root, or square root, cube root, fourth root. That would equal the nth root of a divided by b. and a divided by b is now inside the radical. So just like multiplication combines under one radical, division also combines under one radical, as long as it's the same root. So an example, if I have the fourth root of 48 and I divide that by the fourth root of 3, this equals the fourth root of 48 divided by 3. Which then equals the fourth root of 16. Because 48 divided by 3 is 16. And then again, 16 is a perfect fourth root. So we get a nice number 2, because 2 times 2 times 2 times 2 equals 16. Okay, so now I want you to pause the video and try problem 2. Okay, once you've finished, I want you to answer the questions in the Google form that are connected to this video. Okay, bye.